Conductors, insulators and semiconductors described using band diagrams. What's a band diagram and where does it come from? Well, a band diagram comes from the basics of an atom. An atom can be considered to have energy levels. This bottom one here would be the lowest energy level in an atom. And of course the electrons can gain energy and work their way up to successive higher energy levels. But when these atoms come together, like in the form of a crystal of material, then what happens is all these energy levels tend to overlap. And when they overlap, they form not lines, but they form bands. And a convenient way of drawing that is this here. You can see the bottom set of band. This would be called the valence band, which contains the electrons, and the next energy level band would be called the conduction band. And it's in the conduction band that if there's electrons present in there, plenty of free space, then they can be freely moving about and it becomes a good conductor. So knowing that, let's go back to our diagrams of the three materials which we've studied: a metal, an insulator and a semiconductor. Now a metal is an excellent conductor. Why? Because its valence band is almost overlapping the conduction band, and it doesn't take any energy for the electrons in this valence band here to move into the conduction band. And once the electrons are in the conduction band, then you're going to get a good conductor. Compare that with the insulator. Now the insulator, the valence band is jam-packed, full, no spaces, but what prevents the electrons from moving from the valence band into the conduction band? It's this energy gap. And remember, electrons can't exist in the energy gap. So you need to have a lot of energy to get electrons from the valence band and the insulator into the conduction band. And that prevents it from becoming a good conductor. Therefore, it will have high resistance, won't conduct well. On the other hand, if you have a semiconductor, it's very much the same as an insulator, but there's a big difference. The energy gap is much smaller. The valence band is, like the insulator, full, jam-packed with no spaces for the electrons to go, but with a little bit of heat from room temperature, some of the electrons from the valence band can move into the conduction band, and therefore a semiconductor can conduct electricity. That's why it's called a semiconductor. So there's the three band diagrams for a metal, insulator and semiconductor that you must know. For a metal, the valence band is nestling inside or overlaps with the conduction band, therefore the electrons are free to move about the conduction band, an excellent conductor. For an insulator, the valence band is jam-packed and the electrons can't get enough energy to move into the conduction band, therefore it remains an insulator. There'll be no conduction taking place because there's no electrons in the conduction band. For a semiconductor, very much like an insulator, but one big difference: the energy gap is in fact smaller, which allows electrons at room temperature, gaining the heat from the temperature of the room, to move into the conduction band and therefore make it a conductor, although not a very good conductor. There we have it, the energy band diagram for a metal, insulator and semiconductor.